Storage, what does it means? Yesterday we discussed how we can identify the local storage and shared storage. A small briefly discussion about the storage, how we can access storage from the
ठीक है
ESXi
सर, कल
host
किसी ने
for
बताया
the
कि 5000
person who
समथिंग
never
आप
done
6000
his
बता रहे हो,
RCM.
पता नहीं। तो सर इतना में तो सर नया खरीद लें फिर तो।
Two adapters for the redundancy.
ठीक है सर, दोबारा सर मैं अभी
We
से
have
बात कर लूँ। नहीं
physical
सर,
network
डायरेक्ट नहीं आप बात करें और घंटे में।
where we can plug the cable.
ठीक है, मैं अभी बात करके आपको बताता हूँ।
So this is your physical switch. Here we could have SAN or NAS. And in the SAN, we have access point, one or multiple. It is called storage processor 0, storage processor 1, from where you can put one cable and attach. So inside the sandbox, you have a collections of disk known as a disk array.
सबमिट कर दिए क्या तुम?
So
भाई
as a SAN administrator, whenever we get any request for the storage, we must need to ask some information about their server. In our case, our server names are ESXi host. So when we demand storage space, we must need to provide some identification about our ESXi host. Might be if it is a iSCSI storage, so might be the storage team need to know about your ESXi host IQN. In case of fiber channel, might be they need WWN, which we can generally in the HB adapter. Or might be simple IP address FQDN also they can ask. So you must need to know from where we can provide this information. For ESXi, we have unique name, unique FQDN, unique IP address, so that you must need to provide. And at the SAN level, something it is called like LUN masking. What is a LUN masking? So first of all, as a SAN administrator, we can combine one or multiple disks logically together. Suppose each disk we have 1 terabyte. We combine 2 or more disks in order to form the logical unit number like LUN0, LUN1, LUN-N with different capacity. So if you combine 2 or more disks, then also depends whether you configure at the SAN level RAID 5, RAID 6, RAID 10. Based upon that, it can attach one or multiple disks in order to form this logical unit number LUN1 with capacity, let's say 4 terabyte, LUN1 with capacity 2 terabyte, or maximum we support 64 terabytes. So in a one single sandbox, SAN administrators can create multiple LUNs. SAN application sometimes allows to you to combine all the space together logically. And from this logical space, you start cutting the LUNs, LUNs 1, LUNs 2, LUNs n with different capacity, 4 terabyte, 6 terabyte, 10 terabyte maximum. We can have 64 terabyte. And then the SAN administrator need to use LUN masking based upon whatever information you provided, IQN, WWN. LUN masking means simple. A specific LUN they want to make visible, accessible from specific server. If suppose LUN 0 SAN administrator make accessible, visible from the ESXi 0102. So it means what? This same LUN must be hidden or not accessible from rest of the other physical servers. Because if we make the same LUNs available, visible to the other servers, they can format it. We can lost all the data inside. So LUN masking, we can do as a SAN administrator at the SAN end, or as a vSphere administrator, we also can do in our ESXi level. So ESXi level through command lines, we need to make certain claim rules. I do not want to expose the LUN 0 based data store for the ESXi 02. From the SAN side, it is available, accessible for both from the both ESXi host. But due to some reason, I want to make LUN 0 based data store only as a private data store for the ESXi 01. I need to access ESXi 02, need to make a claim rules, and then LUN 0 based data store I cannot see and I cannot use from the ESXi 02. So once the SAN teams done its job, your job gonna start. So what is your job? Minimum one VM kernel you must need to create. This is a suppose iSCSI SAN IP-based storage. So this using might be, let's say, 20.0.0. network. So how you can provide that network in the ESXi host? So you also need to create the VM kernel port group, let's say VMK8. Assign the IP address 20.0.0.2. So by using this VM kernel, it can access this iSCSI SAN storage. So as a vSphere administrators, we have two options: either reboot your ESXi host, or so it can detect the available or this whatever LUN provisioned by the SAN teams to our these ESXi host that we can see. Or we have an option rescan. But before we doing that, in the ESXi host, you must need to configure how it can discover the target. In the ESXi host, we have always initiator who initiates the connection to the target. Target we have inside the SAN. So we must need to configure the target either FQDN or IP address. So when you perform the rescan, when you perform the discovery, ESXi know very well which IP address I need to approach. So that we suppose already needs to do, already done in the ESXi host. We configure, okay, 20.0.0.1 is your target. So that we need to configure. And we have already created one or two VM kernel port group dedicated to access the iSCSI storage. So once you perform the rescan, you can see whatever the LUNs SAN teams provisioned for your ESXi host that you can see. But right now, these LUN 0 is visible, accessible from both the ESXi host, but it doesn't contain any file system. It is just like you attach new brand disk in your laptop very first time. Until it is not formatted, till the time you cannot use it. So same thing, once this new disk, it is a network-based disk in the form of LUN 0, become visible, accessible, but it doesn't contain any file system. So you need to format it. So since we have this visible from multiple ESXi hosts, so it's not like per ESXi you're going to format. You can use any one ESXi, format it, and make this VMFS data store. So once you formatted it, then you can see there is a VMFS data store.
पोस्ट पे है।
The name of this data store could be any display name, BMFS, let's say 01. With the same name,
करता हूँ।
with the same capacity characteristics, I can see same LUNs with the same display name from rest of the other all ESXi. It could be 2, 20 or more ESXi. And because of this is we created from the LUN 0 and both is busy, this LUN 0 visible from both the ESXi. So this is why it is known as a shared storage. And don't forget, we have local storage also, local disk. Hundred GB. So out of 100 GB, only 5 GB take by the ESXi for itself. When you install ESXi in the local disk, only 5 GB space it takes, and remaining all 95 GB roughly, you can format it as a VMFS, let's say local. So 2 VMFS data store we have.
पानी तो
So now I'm going to deploy the VM.
अच्छा खाली पेट लेना होता है
VM1. I'm going to deploy. So while you're deploying, you have a choice
हमें फूड
out of these 2 VMFS data store where you want to place it. As we know, we want to use all the advanced features of vSphere. So you must need to put in the shared storage. VM1 named directory get created. So now, can I see this VM1 directory folder from the ESXi02?
चीज पे छोड़ दिया
We access ESXi02, open the data store, VMFS-01. Can I see same directory folder VM1 here?
हम जिम ज्वाइन करेंगे ठीक है
Yes. Yes,
हमारा
because
जिम हो
of
ना हो कुछ भी हो
ठीक है, ठीक है।
हाँ हेल्थ इज
same data store, visible,
एकदम अच्छा से
VM1.
चल चलेंगे
But powered off VM, powered on VM. Can you see in the ESXi02? No,
शिफ्ट का क्या चल रहा है
that's not possible. VM always take its required resources only from the single ESXi host. So VM appear only in the single ESXi host where you deployed, where you registered this virtual machine. So it means when you power on this virtual machine, what exactly happened? Like when you power on your laptop, what happened? Your complete operating system get loaded into a physical RAM of your laptop, but from where? From the disk. The same thing happened here, with the difference we are using network disk. You can see somewhere we have this folder in the LUN 0, which is you can expect in these 2 disks. So when you turn on the virtual machine, so let's say this is the portion we have as a RAM. We are using, let's say, 20 GB RAM, or could be 2 terabyte RAM in your production environment. This virtual machine need only 5 GB. So when you power on, it is the ESXi host going to access flat.bmdk over the network, boot it over the network, fetch its all data over the network and load into the RAM. So this portion suppose belongs to your VM1. So running powered on instance always we have in a physical RAM. So when user connected to this VM through RDP to PuTTY, so it means the user working in a memory state of the virtual machine, which completely exists in the ESXi host physical RAM. So now you deploy one more virtual machine, VMs2. Again, you put in the shared storage. So you can see one more folder, VMs2 get created. VMs2. But physically, they are inside the SAN storage. And when you power on the VM2, so again, it is the ESXi2 going to fetch its all the data from the flat.bmdk, load into the physical RAM. So this is your VMs2. Now we have powered on virtual machine instance. And one virtual machine, VM3, we just placed in the local VMFS data store, VM3. So all virtual machine performing IOPS, VM1, VM2 performing IOPS in the SAN storage, VM3 performing its IOPS in a local storage. And what happened? Suddenly my ESXi01 failed. I do not have any HADRS cluster. Without HADRS cluster, so suddenly hardware failure occurs in one of the ESXi hosts. What happens to my VM1, VM3? You lost
So
your
all will
VM1,
come.
VM3?
Yep.
Sorry?
Yes, it will be lost.
Yeah, you lost your VM1 memory state. VM3 also we have running here in the physical RAM. So RAM is a temporary memory as we know. So once this hardware failure occurred to this ESXi01, immediately user who were working on those virtual machine lost their virtual machine. They make a call to you, you're going to investigate, and after investigation, you found that yes, ESXi no more available. So what you can do now, how you can recover the virtual machine? Can we recover virtual machine? So what the process normally we can use? Immediately as a vSphere administrator, we can access ESXi02. Browse this data store. Browse this VM1 folder. Both folders are visible from both the ESXi host. So one host failed. You're going to browse the folders. VMX file, right click, you have registered VM, select this time ESXi02. So suddenly your powered off virtual machine VM1 appear in this ESXi02, and then right click on a VM, power on. So VM1 related all data, ESXi02 fetch from the flat.bmdk of VM1, load into its own memory, and you can see VM again come up. Hardly take 1 to 2 minutes to perform this whole process. So without any backup, you can see both virtual machines I have now running successfully in the ESXi02. You can send a mail to the user. So user again make a RDP connection successfully towards virtual machine. But by using same process, you can recover only VM1. VM3, not possible because that you placed in a local disk. So vMotions, DRS based vMotion, HA, even will not work if you place virtual machine in a local storage. So this required more downtime. You can see VM1 within a 1-2 minute you can provide again to the customer, but VM3 needs more downtime. Might be you going to use the backup and restore process, then only you can recover the virtual machines. That's why we would like to use all the time shared data store in order to use the vSphere advanced features such as vMotion, HA, and DRS.
Personal, automated.
Now, this is the, you can say, high level overview about the storage. And when you say another thing, how just you have seen when one of the hardware failed, how we recover the virtual machine manually. And the same thing, if you want to automate, then we need vSphere HA cluster. That tomorrow we're going to see. So HA cluster use its own methods, process. It automatically detect the failure host, automatically detect what virtual machine were running on that, but make sure VM must be on the shared storage. Only if VM we have in a shared storage, that get automatically registered in the another survived ESXi host and automatically registered, and power on action get triggered. You can see hardly 1 minute. HA will take 1 minute, and another 1 minute might be VMs need to complete its boot process. So hardly 1 to 2 minutes, you can see VMs automatically come up in the another hardware, in the another ESXi host. So HA cluster DRS we're going to see tomorrow, but this is your storage. Virtual machines are performing its read-write on its flat.bmdk. So when the virtual machine generated its IOPS, these IOPS intercepted by the ESXi host, and then over the network, it applied those IOPS on the flat.bmdk, which is exist in the sandbox. So when you say we have IP-based storage, it means I can have iSCSI storage, I can have NFS storage, or even I can have fiber channel over Ethernet storage. Only fiber channel storage if you have, then it has no dependency on the TCP IP stack. Fiber channel storage doesn't need VM kernel port group, but rest of the other storage, whether it is NFS, iSCSI, fiber channel over Ethernet, needs VM kernel port group. This is how the virtual machine can perform its IOPS on its sandbox or in its NAS box. You can use the similar way your NFS storage. NFS is not the VMware own file system. It is called as a third-party file system. So it means what? NFS storage you cannot format from the ESXi host. Like VMFS, we formatted LUN0 with the VMFS data store. VMFS is the native file system of your ESXi. But NFS, generally known as third file system, but we can access it. As NFS storage, we need to prepare some NFS mount point here. Let's say NFS1, NFS2, and over the network, I can access it because here inside the ESXi host, we have NFS client. NFS client version 3, client version 4.1. So that depends while you initiating or while you right click on a data center, you have the option create new data store. It launches the wizard. In the wizard first option, if you want SAN data store. Second option we have for the NFS. So if you select second option, then it will give you the option NFS client 3, NFS client 4.1, which one you want to use. If you select 3, make sure from the rest of the other ESXi, we select a 3. From some ESXi using 4, some ESXi you are using 3, but in the backend you are going to point and access the same NFS point, you are going to corrupt it. So it is recommendation, either use 3 from all the ESXi host NFS client version 3 or NFS client version 4. Don't mix. So in the same wizard, when you select the NFS client version, then you must need to provide the NFS detail. Let's say it using 30.0.0.1. So first of all, you must need to create one another VMK, let's say 6, where you can give 30.0.0 network. So by using this network, I can access 30.0.0.1. Then you have to provide either FQDN or IP address, then your mount point directory, exact name, location you need to provide. You have your option. Are you going to mount it as a read only or read write? So initially we need to, default is read write, but if you want to make sometime NFS, we make as a library servers. So in that case, first we needed to mount it as a default read write, load some data, ISO file template, unmount it, again mount it as a read only. And then whatever stuff you already put like ISO file or template, that every SXI can use if they want. But there is no one administrator who can put any more data inside. Whatever data you have already placed, that data only admin can use, because you mounted this time this NFS as a read only.
मैंने बस ट्रेनिंग
So
दी
these kind of data store known as a IP-based data store.
मैं नहीं करता
Once you finish the wizard, you can see there is a one more data store up here, whatever display name you have given, and you can use this NFS data store also to place your virtual machine, or it's up to you, or you want to make it as a library server. You just want to place some templates, some ISO files, so everyone can use it. So in your production-based ESXi,
हाँ ठीक है
it's not like you have only one category of storage. You could have multiple storage available. Some storage might be you are using fiber channel storage. Fiber channel storage known as a most expensive storage solution it is, and a reliable storage it is, but most expensive, because if you are using fiber channel storage, you cannot use simple Ethernet switch. You need to use fiber channel switch, optical fiber cable end to end. You cannot use copper cable, and you cannot use Ethernet adapter. You need to use HBA adapter, expensive. HBA adapter expensive, optical fiber expensive, and fiber channel switch also expensive. So when you use fiber channel, when you use iSCSI storage, fiber channel over Ethernet storage, or your NFS storage, you can see NFS is different. It is called actually the difference between BMFS data store and NFS. BMFS gives you the your block level access. NFS gives you the file level access, because you cannot format it NFS from the ESXi. But BMFS, yes, it is the native file system of ESXi. We can format it. So when you use the term fiber channel, iSCSI fiber channel over Ethernet, it means the media you are using different. Inside the ESXi, whatever we discussed remain everything as it is. Inside the SAN, whatever we discussed, you have collection of disk known as disk array. You can create first target. Target also you have like type T0, T1, T2. And then under the target, you can have one or multiple LUNs. So this concept remain as it is. At inside the ESXi, whatever we discussed remain as it is. Only the media who's responsible to carry the instruction host to storage, storage to host, that can be different. Like in a case of fiber channel, you have different media. In case of iSCSI, you have a different media. In case of AppCoE, you have different media. So as we know, in our lab environment, you do not have access to this part. You also doesn't know about this. You have just visibility for these LUN 0, LUN 1, LUN 2, but you have no access to access SAN storage, SAN application. So as a vSphere administrator, most of the work we need to done at the hypervisor level. So after this entire module, you're going to see some relevant problems. So problems like
ग्रुप में होगा ना टीम
what adapter you are using to access the sandbox NFS. Somewhere you need to find adapter is up and down. A relevant VM kernel is up and down. Or some, when you run the script, the script totally removed one of the VM kernel. Through this VM kernel, you are accessing
बोला
this
है वो
storage.
देखेगा अपने एप्लीकेशन
Or VM kernel is there, everything is there, but someone put the wrong VLAN tag. In your lab environment, we do not expect any VLAN tag, so you just need to observe it. So if there is a VLAN tag, simply add it, remove VLAN tag. Or sometimes targeted IP address is wrong, or the port number is wrong. iSCSI port number is wrong. And before they start communicating, or if you want, we can configure CHAP, Challenge Handshake Authentication Protocol, unidirectional, bidirectional. And that before they start communication, they need to prove their identity to each others for the secure communication. If you enabled CHAP. So CHAP enabled in one hand, is it correctly configured or not? That also we need to verify. So this is you can see much more detailed information because we cannot spend much more time on this. But somehow, you know how virtual machine perform IOPS over the network from ESXi host to vSAN storage or NFS storage. So if you have any questions from our this discussion, you can ask or we can continue them. Okay. So we have now, in this module, we have 3 lessons: storage, connectivity, and configuration, ESXi storage, and VM snapshots, and multi-pathing issues. Okay. So, okay, bit later we can discuss when we start lesson 3, then I will explain the multi-pathing. First, we need to understand what is multi-pathing. Then we can, once we have understanding regarding multipathing, how we can configure different way to achieve multipathing in case of iSCSI, in case of NFS. So that we're going to see. So storage, first lesson we have storage, connectivity, and configurations. So you can see vSphere storage architectures. The types of data store which we can use in a vSphere environment, it could be a vSAN. How many of you are aware about vSAN data store? Is there anyone? I think 1 or 2 person done this. Huh? Yeah. So in case of vSAN storage, vSAN architecture slightly, you can say, slightly totally different. So in case of vSAN storage, you are not going to buy expensive dedicated storage, NFS, NAS, or SAN. You just place bunch of disks locally in the ESXi host, and you're going to. So small discussion for that. People can know about vSAN. So in a vSAN, you do not have any dedicated storage. Now see the challenge if you are using SAN or NFS, whenever you're going to deploy new applications, you need new storage. You need to wait. You need to make a request. I need this new storage with this capacity. And then it get approved by the process or storage team going to provision. You need to wait. It means might be one entire days. Today you request, tomorrow, day after tomorrow, you're going to get a storage. So in your this vSAN, if you are managing vSphere, you are the one who going to manage the storage also. You have no dependency on the storage team. You are the one who managing storage. You are the one who managing complete vSphere stack. So whenever you need for the new data store, you can have storage available. No need to ask for the storage team. So now vSAN, we are going to use local disk. So let's say here we have a few local disk. Within the same ESXi box, you have local disk. And this is a software-oriented storage. The minimum you need 3 ESXi hosts in the vSAN clusters, or maximum you can have 64 7.0. So, and we need one vSAN network. So another VMK, let's say VMK2, VMK2 network. It is called vSAN network. So when you configure vSAN cluster, vSAN process going to scan your hardware, detect how many disks do you have, what is the capacity of this disk. So suppose we have a capacity 1 terabyte, all the disks with capacity 1 terabyte. So 2 plus 2, 4 plus 2, 6. It will show to you as the aggregate of all the local disk space with capacity roughly 6 terabyte capacity. So in the vSAN storage, you can see single vSAN storage with capacity 6 terabyte. So they over the vSAN network talk to each other, vSAN process that I have 2 disks with this capacity. So they combine this and make a one logical vSAN data store with capacity roughly 6 terabyte. And then you're going to, when you're going to create a VM, so you must need to use the vSAN storage policy. If you don't select any, the default policy is called FTT1. It means failure to tolerate 1 out of 3, 1 goes down, still your VM can survive. And if you want, you can configure FTT2, FTT3. But in order to use FTT2, you need minimum 5 ESXi host. You need minimum 7 ESXi host. Then only you can configure any FTT1, FTT2, FTT3. And VM level is a VM level. First VM, I configured the policy FTT1, another few virtual machine FTT2, another virtual machine FTT3. What does it mean? Let's take a default policy. Default policy need minimum 3 ESXi host. So when you deploy the virtual machine VM1, so with the FTT1 policy, so this VM1, it get created in the local disk, VM1. Folder get created, suppose it occupied 100 GB space, replicate data over the vSAN network. And second ESXi also having the same data as a replica to VM1. Also occupied 100 GB. Third ESXi host, keep a small file, 18 MB. And this is called a witness. This file keeps the information about both the replica and virtual machines related all objects. So you powered on the virtual machine, it fetch all the data from this disk and load into the, so this is a RAM, 20 GB, load into this RAM. The virtual machine is powered on, performing IOPS. Whenever any information it need to write in this flat.bmdk, also write in the second flat.bmdk in the second replica. But there is another mandatory condition. You must need one disk SSD or flash disk SSD. This is called cached tier disk. It is your SSD. High performance, costly, and this is a mandatory condition. And this is, we are using not to place virtual machine, but maintain the cache. And caching, whenever we use this term in any form, it means we want to improve the performance. Similar data again and again, you do not need to go to the flat.bmdk. We maintain here that as a cached information. 70% read cache, 30% write buffers. Whenever virtual machine, let's say user connected to the VM, connect to YouTube and download some videos. That data comes to the physical RAM to the write buffer, and write buffer to the flat.bmdk. So this way we can improve read performance, write performance. So we have a two replica. Whatever data it needs to write in a replica 1, the same data get replicated on replica 2. So both are the mirror copy. And at any time, we lost our ESXi host. Now, HA and vSAN process works together, read the witness file, see the location of the second replica, registered virtual machine on second ESXi host, and power on. So hardly again, after 1 minute, virtual machine again come up in the another ESXi host from the replica. So this is about your vSAN storage. vSAN storage, we do not need to buy the expensive SAN NAS storage. We are playing with a local disk. So some local disk we can place in the each and every ESXi host, and then this is the vSphere feature. It means you do not need to download some appliance, some application. No. How you can configure like vSphere, HA, other features, DRS, vMotion. So this is also one of the built-in features. You just need to access vCenter server, and from the vCenter server, you start configuring your vSAN storage. So whenever you need storage, you as a vSphere admin can manage it. Storage as well as vSphere entire infrastructures. So you could have vSAN, you could have virtual
I have
volume.
one question regarding that vSAN. So this
Yes, please.
ETMB witness, right? Is it created on master server or is
No,
it
no, no, no,
available
no,
on
no,
all
no.
the host?
All the host.
So
Like
these,
some virtual machine might be we have here.
Mhm.
It's a replica is here, second replica here, witness on third ESXi. So all ESXi can contain witness file. You can have for some virtual machine witness here, for some virtual machine witness file here, for some virtual machine witness file here. All ESXi can contain a replica of the virtual machine. All ESXi can contain witness host, a witness file also. So there is not like this is a dedicated only witness. No, witness host.
So this witness is kind of a heartbeat, right? For this virtual machines, right? If any host goes down, right?
If any host goes down, so how we comes to know where this virtual machine's replica exists, in which host the replica of this failed virtual machine exists. So we read this witness file, and witness file also participate for the election voting. Actually, in the vSAN, there is a quorum cluster concept being used. Quorum cluster concept say 50% plus voting must be available, then only the object can survive in the failure scenario. So every object, replica 1, replica 2, witness participate for the voting. So if you lost one ESXi, you lost one vote, 50% plus booting still available, because 2 booting still you have available. So it means your virtual machine still can survive.
Okay. So this 18 MB witnesses, is it at a ESXi partition level or a data store level? This one.
No, data store level, not partition, data store level.
Thank you.
Welcome. So vSAN even has its separate 5 days course even, right? So this is just high level overview. So many policy, even it also support. This what we discussed, it is using RAID 0, RAID 1 concept if you are aware about, but it also support the RAID 5, RAID 6. So many we have inside, but this is yes. So at least you get the idea when you use the term vSAN, what does it means?
Exactly. So as far as I know, right, for FTT2, right, at least we should have a RAID 1, right, for RAID
No. In FTT1, FTT2, FTT3, in all these cases, we are using RAID 0, RAID 1 only.
Okay.
RAID means RAID 1 means mirroring. So you have mirror copy
Right.
across the ESXi host. In the RAID 0, you can, what is the RAID 0?
Striping 1.
Huh?
Striping.
Striping, not what you can say. Yeah, correct. Striping. So it means what? You can expand the virtual machines related object in more than one disk. So minimum 1 or maximum you could have striping 12.
Right.
So here suppose we are using striping 2 disks. So what does it mean? Half of the flat.bmdk we have in a one disk, half of the flat.bmdk you have in a second disk. The benefit, striping benefits only we can take if per disk you are using a separate controller.
Right.
Per disk, if you are using separate controller, you can see half of the data we have placed in a one disk, half of the data of the same virtual machine be placed on the second disk. So it means to read and write the data, instead of one disk controller, I am using 2 disk controllers. Automatically, it will improve your read-write performance.
Okay.
So basically in the vSAN we use RAID 0, RAID 1 concept with FTT1, FTT2, FTT3, but separately we also allow you can use RAID 5, RAID 6. So when you choose RAID 5, RAID 6, that time you cannot choose FTT1, FTT2, FTT3. Because RAID 5 itself gives you 2 disk failure.
Okay. Now I got it.
Right?
So
RAID 1 disk failure or 2 disk failure. RAID 6 gives you 2 disk
so
failure.
this
right?
feature, right, FTT 1 and 2 and 3 is only part of RAID 0 and RAID 1, right? And RAID 5,
Yes, correct.
RAID 5 and RAID 6 once we are configuring, then we are
Yeah.
removing the option of FTT 1 and 2 and 3, right?
These automatically become grayed out when you select RAID 5, RAID 6. These are not available automatically.
So, the case, right, the failures once it's happened, right, because we do have environment. I'm not sure what we have configured either with the RAID 5 or RAID 1. But in a case of failures, right, we always machine was running and we removed from software level and replaced the hard disk and again resync back the vSAN. So that
Yes, correct. If suppose one of the disks failed,
right.
one disk, not entire ESXi.
Right.
So it does not impact your running virtual machine, because whatever data you missed here, it start using that data from the replica, and you need to just as a hot plugin remove the disk, failure disk, and replace it with the new brand disk. When the new disk appear, it automatically rebuild the missing data inside from the other replica.
So
Yeah.
in this case, right, once we add and remove, right, this witness one is only I believe witness is the only one who ask VM kernel to replicate the data, right? To back to
Yes.
the architecture is like that, right?
No. Architecture, when you see, there are so many components belongs to your vSAN. But you can say it is done actually by the vSAN process running in the all ESXi host. Once we configure vSAN cluster, so vSAN process running in all the ESXi host who's taking care. From where you need to perform read, from where you can perform the write. So there's a lot of concept behind that.
Exactly. That's
Okay.
Thank you so much.
Yeah.
Okay.
So you can see the supported types of data store. You can have vSAN, you can have virtual volume. Now this is not get very popular. So now in the latest version, this discontinue from the, you can see next version 8. VMFS and NFS. So these are the types of data store. Are you using NFS? Are you using VMFS? You are using vSAN? You are using virtual volume? Now, which technology, the media you are using to carry the instruction host to storage? Are you using fiber channel technology for that to carry the instruction, or you are using Ethernet technology, or in case of vSAN, you have directly attached disk locally available within a ESXi host. So media can be vary. That depends. Like when you say I'm using iSCSI data store, so media only get changed. When you say I'm using FCOE, fiber channel over Ethernet, you have special adapters to use the fiber channel over Ethernet technologies. That is called what? CNA adapter required. Special category of adapter. Converged network adapter. Fiber channel, HPA adapter, fiber channel switch, optical fiber cable, and FCOE support both optical fiber as well as copper cable. So only media get changed, but the concept, if you say, still we are accessing the LAN from our ESXi host and virtual machine writing its data on these LAN-based data store. Or we can use similarly NFS also. NFS is not the VMware on file system, but yes, we can from the hypervisor ESXi can access it as a file servers, and virtual machine also we can place in that type of data store to place the IOPS. So when we're talking about iSCSI storage, so you can see inside the storage, whatever we discussed remain as it is. Collection of disk known as a disk array, and you're going to create target. Under the target, you're going to form a LUNs. LUNs contain a logical space from one or multiple disk, LUN 0, LUN 1, LUN 2. Multiple LUNs we can have in the same sandbox. And these LUNs we need to provision from the for our ESXi host. So at the ESXi level, if you are using iSCSI, we have initiator. We could have hardware initiator, software initiator. That depends what kind of LAN card adapters you are using. Initiator always initiate the connection to the target, and target is your storage. So when we ask from the storage team that we need some storage, so you need to provide this kind of information. That depends, the storage team needs what? IQN, you need to generate first IQN in the ESXi host. Or you can provide iSCSI alias name, or you can provide even IP address. So that depends based upon what information the storage team going to mask the LUN. ESXi host cannot access the IP storage, IP-based storage. So IP-based storage means to access storage hypervisor using TCP IP stack. Mean you must need to use minimum 1 for redundancy, 2 VM kernel port dedicated to access iSCSI fiber channel over Ethernet NFS storage, except pure fiber channel. That has no dependency on the IP, TCP/IP stack. So we can run this command ESX CLI storage core path list, and the output you can see where you can see the which LUN is available, visible from your ESXi host, and what path we are using to access this LUN 0 from the ESXi. You can see this is also called runtime name. So it using this ESXi using to access LUN 0, VM HBA adapter 65, channel 0, target 0, and under target 0, it is a LUN 0. This is the exact path it using. And the particular NNA ID you want to see about that LUN, so that also visible through these commands. Sometime you want to remove a particular LUNs from the ESXi host, or you want to make its partitions. So that time you must need to recognize with its unique NNA ID. Per LUN we have unique NNA ID, and some vendors it start as a T10. What plugin, native multipath plugin it using, and state is active. So this kind of informations we can retrieve through this commands. When you run this command, the output is like this. Check whether a rescan restore visibility. Yes, that is the first step you can do. Whenever any data store related issue you have, go to the ESXi configuration storage, and there is the option rescan. Click on that. So it's going to again try to find the available data store again. So most of the time, rescan will fix your problem. So what you can do, you have a multiple data store, one specific data store only not accessible. So why unnecessary? You want to perform rescan for others data store also. So pick up a specific VM HBA and specific adapters you are going to perform on that rescan. And also we can check the free space. df-h trap VMFS. So how many BMFS volume we have available? I want to see that only as a list, and it will show to you how much they have free space available. And their display name in the vCenter server ESXi, how, with which name they appear, how much space we have free, that all we can see through this command df-h. So identifying possible causes. If the ESXi host access IP storage in the past and you made no recent changes to the host configuration, you might take bottom-up approach. Possible causes: the VM kernel interface for IP storage is misconfigured. Do not need to start investigation from the VM, directly at the host level. You are using IP-based storage. Which VM kernel you are using to access that storage? Check that. IP storage is misconfigured on the host, or is it listening on the 3260? In case of iSCSI storage only, we use this port as a default port. We can check. Make sure the firewall in the ESXi host not stopping or blocking this iSCSI traffic. NFS storage is not configured correctly, might be mounted as read only. NFS data store metadata is consistent or inconsistent. That also we're going to see through command. You can check it, whether the data inside the data store is consistent or inconsistent. iSCSI storage array is not supported. The LUN is not presented to the ESXi host, or physical hardware is not functioning correctly, LAN card, or could be at the storage and we have a problem, or poor iSCSI storage performance is observed. And you can see this is one of the command often be used, ESXtop or RESXtop if you are remotely going to use it by using ESXCLI software. So generally we can access directly and run the ESXtop, and then by default it gives you the CPU related only statistics, but we want disk or storage related statistics, then you need to enter a different switch. Press D to view the disk adapters, like whatever the adapters currently have utilized. So you can see BMHBS65, where number of commands per second it handling, read, write, in MB data, so that all statistics we can see. Enter U to view the disk devices. So when you enter U, so you can see, yesterday I discussed how we can identify which disk is a local. The first 4 disks are local. Especially if you are using vSAN storage, you can see all the disks started as MPX, 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 MPX. In the disk or storage coming from the SAN, so you can find NNA, NNA, NNA. And each of the LUNs has a unique ID. Hardware level problems. Check VMware compatibility guide. Each and every kind of hardware we cannot use in the ESXi. So before we buying any hardware, we must need to check online in the hardware compatibility list. Verify that LUN presented correctly to the ESXi host, and that is the job get done by the storage team. So in our side, make sure the requested information be provided correctly, whether it is IQN, WWN, or other information. The LUN is in the same storage group as all the ESXi host. Generally, this happens as when we using shared storage. Generally, we use shared storage. The LUN is configured correctly for use with that ESXi, properly LUN masking, and that is also storage team job. We just want to make the confirmation whether in the storage and everything configured correctly. Cross-check it, all the information. The LUN is not set to the read only. So it is also possible storage team if want to make the LUNs read only, it means we cannot put any data from the hypervisor to this LUNs. The host ID on the array for the ESXi host maximum would be in that range. And maximum LUN per ESXi 7.0 we can see. If the storage device is malfunctioning, use the hardware diagnostic tools that we get from the vendor, from which vendor you buy the hardware, ESXi machine. That hardware vendor gives you the one CD. You can just insert the CD, it will automatically detect if there is a malfunction, faulty hardware, fault in the hardware, it automatically detects. Which VMK you are using to access the iSCSI storage. So first VM kernel, make sure we have correct IP address subnet mask, you can add it. And it must need minimum one VMNIC, VMNIC, physical LAN card mapped. Minimum one, or for redundancy, yes, 2. So a misconfigured VM kernel interface IP storage affects any IP storage, whether it is iSCSI or NFS. To test, generally we use the ping. If the ping command fails, verify that IP settings are correct or not. So this is what we are going to perform. We cannot perform testing at the storage end. We have no accessibility, but yes, host end we can perform that all test. And here you can see initiator name, and we are using iSCSI software based initiator. We need to enable it and see the very first thing you can do, rescan storage or rescan adapter. So most of the time when you click this option or use this option, your data store come back. But if not, then further we need to make sure target IP address you configure correctly and the port number is correctly configured. That you must need to verify. And when you run the script sometime in this, remember here or here, change the IP address or remove this entire information. But everything is there, but the port is different. That we need to also verify. And generally in our lab environment, we do not use CHAP challenge handshake authentication protocol. But yes, when you run the script going to enable it incorrectly. Whenever you find any CHAP, you can just from drop down list select no chat and disable it. No CHAP. Because we can enable it, but on the same end, we do not have any access. So better way to keep it disabled if it is get enabled. And then we have a port binding. Frequently asked in an interview, how I can achieve multi-pathing in iSCSI storage. So first of all, what does it mean when you use the term multi-pathing? So we need to discuss this here because port binding now we have here. So later on the third lesson, when again we face, so we do not need to again discuss the same thing, port binding. So now see, if you have two desktop 1 and desktop 2, and both are connected to the LAN. So even this has, let's say, one more LAN card connected to the desktop 2. I have 100 GB data to transfer from desktop 1 to desktop 2. Even this desktop have two LAN cards. Can it use both of the LAN card together to transmit all 100 GB data from desktop 1 to desktop 2?
एक ही बार के लिए होता है
10001, 10002, 10003, 10004. So when you make a accessibility from desktop 1 to desktop 2, 10002, you're going to access. So it's going to find, do I have 10 network access from the top LAN card 0, LAN card 1? Yes, LAN card 0 contain 10 network. It start moving and using this one. Even it has one more LAN card, but it stopped finding it because it needs just one at least network available with 10 network. Once it found, start moving the data. Even you have one more LAN card, but it's not using it. So same thing, in order to use multi-pathing from your ESXi host, even you have VMK3, VMK4, and 2 dedicated LAN card to send data to the storage somewhere in the network, but it always use first one. Once it start detecting, let's say it is using 20001, we have 20002, 20003. Start finding from the top. Do I have 20 network? Yes, it found. VMK3, start using it. Even it has one more
वो अब आ जाना चाहिए
VM
बिना ब्लड के भी
port
ऐसे उंगली
with the same network, but it not using that one. So even you have one more path available, why not using this one to improve your IOPS read write on the storage? So that's what we need here, port binding. To achieve multipathing in iSCSI, we need to use port binding. Now, this is also frequently asked in the question, how we can achieve multipathing in case of iSCSI storage. So they want to listen from you port binding term. Once you use port binding, they know, okay, you know the concept. So what is a port binding? These two dedicated only to access the iSCSI storage. So VMK3 tightly binded to the VMNIC 6, and this is tightly binded to the VMNIC 7. So we binding these two and forcing them by using port binding. Use both these dedicated network VM kernel to perform your IOPS read write of your virtual machine. So make sure this is configured or not.
ऐसे बॉईल करते हैं
गर्म पानी इसमें डाल देते हैं
बॉईल कर
Error in the storage port group configurations. Verify that network port group is configured properly. In this example, one of the port group configured is shown. Among setting configured on this port groups are elastic port allocation. What is elastic port allocation? So initially in your switch, it assign 8 port. If you occupy 8 port, elastic is enabled. It automatically give you next 8 port. But sometimes elastic not enable. So it only gives you 8 port. You are not able to attach additional VM kernel, additional virtual machine if all 8 ports are occupied fully, if elastic is not enabled. Then blocking port is allowed. That also at the switch level, you can block the all ports, immediately stop communication of your all virtual machine, all network. And make sure you configured or not configured traffic shaping. So through traffic shaping, what are you going to achieve? You are going to put the limit for specific type of traffic. You are putting limit not to use beyond this configures parameter. So make sure you have configured. Yes, then is it sufficient or not? So that also we can check. So here you can see everything except then block ports, that is mandatory allowed. Rest other things disabled, disabled, disabled. If it is enabled, then make sure traffic shaping configured for this individual port group which we are using to access the storage. So make sure we have sufficient bandwidth available or not, or do we need to modify the traffic shaping or wrong VLAN tag? No theming policy, no redundancy. So each information we can track from here, property of the virtual machine port group or VM kernel port group. Sorry. MTU size. We also can check, and it is always recommended to make a jumbo frame for the IP-based storage such as iSCSI NFS. So right now we can see it is the default configuration, 1500 bytes. You can make it a jumbo frame with configure this as in 9000 bytes. So this way also we can improve our IOPS performance. CDP, whether you enable or not, if you enabled, it has 3 states: listen, broadcast, listen and broadcast, mean both. Have you configured it? Yes. In which state? Listen, only to listening about the physical network, but its own information, it not broadcasting to the physical network. So physical network team want to see in another end, what kind of switches you are using, they cannot see because you configure only one way. So sometimes you need to configure it, listen and broadcast. It can retrieve all the physical switches information, also its own characteristics, whatever you have, forward to the physical switch. So physical switch team also can see your virtual switch characteristics configuration. Error in VM kernel adapters. Are you using IP address for the VM kernel on the DHCP or through the static? And make sure right subnet mask default gateway DNS at the VM kernel ports group. Otherwise, DNS not mentioned and you mentioned discovery target FQDN iSCSI.vclass.local. DNS is not configured, so how it can resolve the FQDN to IP queries. So best practices for the storage to be on non-routed network. Yes, ESXi to storage do not need to place router. So we need to make a layer 2 network between the ESXi to storage. So no need to use these routers. You can use node name and IP address to configure iSCSI target. One of the previous slide we have seen where we can configure the target IP address, not necessarily IP. You can configure the FQDN because IP might be changed as per policy change. The IP got changed. Like we do never need to know what is the IP address of google.com, what is the IP address of vmware.com. Internally, the IP address frequently changes, but we always hit the FQDN. For FQDN, make sure DNS is properly working and mentioned configured in the VM kernel adapter. And physical network VM NIC 6, which we're using for the storage, we can see its all characteristics. CDP, LLDP supported by your distributed switch. CDP supported by about, and you can check their connectivity. Here actually the snapshot given from the lab environment where ESXi itself a virtual machine. That's why you can see BMXNet. This is generally for the virtual machine. But physical adapters show most of the same, but driver is not BMXNet. Driver is something else. Verify that physical network adapter is configured properly, and the full information on the type and configuration physical network adapter we can see like that way. Some adapters and configurations are not supported. And this is where we can see the target is listening on the port. A failure, okay, you can see port unreachable. So through command line, we can see the iSCSI port is reachable. Is it listening on this port, the target, or not? So IP address of the iSCSI storage array, we can verify to resolve this problem by checking the path between host and hardware. Verify iSCSI storage array is configured properly and is active, and firewall not blocking the iSCSI traffic. At the host level, these verification we can make. The data within a data store is in inconsistent state or inconsistent. Data get corrupted or not. It is in a healthy state. So this is the commands we can use. So it will show it's all the output in this location, whatever you have given, and in this file it write everything. So once you run this command, after that you need to open this command and to see whether the data state is consistent or inconsistent. If it is inconsistent, the backup and restore is the only solution. Remove the existing data store, recreate it, or you need to, if you need to replace the disk, or that you can do, but again recreate and restore data from the your backup. So a file system's metadata should be checked in a following situation whenever recently disk replacement taken place. Reports of metadata error in the VM kernel.log file when you read. Inability to access file on the VMFS volume that are not in used by any other host. If you encounter BMS inconsistency, perform these tasks. Recreate the BMFS data to restore file only from the latest backup. And if it is required, we can open the support ticket for the VMware if you think that you do not have enough knowledge to verify whether the data really corrupted or not. And here, you can see that yesterday I said this is from where you can check device backing under the configure, the NNA ID or MPX. Is it a local disk or this disk or LUN coming from the storage? And we also can see the runtime name, channel, target, and LUN. It could be channel 2, target 1, LUN 11. So this we can identify through the NAID, to the EUI ID, and runtime name might not be same as the device ID. Yeah, so most reliable name is NNID, this one. And runtime name is not reliable information. So at the storage end, you have two paths. This is the channel 0, channel 1, and it is not available. And you remember this one. And when you run in the command, you can't see the channel 0 because it is a channel 1. So runtime name, we do not need to use. Always identify the data stored with the NNAID, because runtime name generated by the ESXi host, and it is not static. Whenever we lost some path and whatever name we remember, that is might be does not exist. But NNAID coming from the SAN, we cannot rename it, and it remain all the time static. So most reliable name to identify any data stored with the NNAID. Determine the device name. So again, you can see ESXCLI storage core path list, and through command line also we can see the NNAID. Use BOMA utility to find the error. So when we run these commands, just to check whether we have some error in the disk or that particular network disk known as a LUNs or not. So we can run these commands. So you can see error found 0. So it is a healthy. And this is your NFS.
This WOMA command
Yes,
can
please.
be used for vSAN as well, or is not applicable for vSAN?
Yes, we can use. For the vSAN also we can use.
Okay, thank you.
Yeah. So NFS, since we know it is also known as IP-based storage, but it is not the file system of ESXi. Means as ESXi cannot format the storage with its NFS. NFS is not its ESXi own file system. It is known as a third-party file system. But as ESXi, we have NFS client here. So with the NFS client, we can access the NFS storage, but we need VM kernel because it is IP-based storage. Minimum 1 for redundancy, 2 for the multi-pathing, 2 VM kernel, 2 LAN card. And then we need to provide the detail, NFS server, FQDN or IP address, and the directory name. And it's a case sensitive. If you created as a NFS administrator, the mounted directory / under the root ISO small. So same case sensitivities while you adding in the wizard, you have to type complete path. Here we have just root / in small I, small s, small o. If it is a capital letter, then same as it is, we need to mention here. So over the TCP IP network from the ESXi host, we also can access and use NFS storage. So as I explained, you have a both option. Default is read write, but sometimes we want to make NFS as a library server. We want to place ISO file and template only, not the virtual machine. So we can first time mount it as a read write, put all the required data, dismount it, again mount it as a read only. So now everyone can access the data store, and existing stuff only can use, but new stuff they cannot put inside. I mean, simply we cannot place any virtual machine because VM need both read write access. So both way we can use this NFS. So read only or read write. Default is read write. So NFS client in your ESXi host, we have now two, version 3 or version 4.1. So using version 3 or version 4, that depends which features supported by the version 3 or version 4. So you can see if you are using version 3, so most of the vSphere feature we can use, whether it is HA, FT, DRS, DPM, all the features. Additional solutions such as Site Recovery Manager, you can use. But if you are using NFS version 4.1, and this is the list of 7.1, if you find 8.0, some more feature now supported, like site recovery also now starts supporting. But yes, in a 7.0, some feature are not compatible if you are using NFS version 4.1. So when you launch the wizard, create a new data store, right click on at the data center, new data store. So you have these options. First of all, select the type here when you're going to select. So you have multiple options like SAN, NFS, vWall. So you have to select NFS, then it will show to you client, NFS 4.1 or NFS 3. If you select 3, then other ESXi host, when you're going to configure, you must need to use 3. If you are using 4, then rest of the other ESXi, the same data store, access by using the same version. Otherwise, it can be up to data. So that is what the best practice. Configure NFS array to allow only one NFS protocol, either this one or that one. Data corruption might occur if host attempt to access same NFS share mount point using different NFS client version. That we also need to take care. NFS client authentication. So we support now the client authentication, server trust UID or GID, including the RPC request, and client trust the response received from the NFS servers. And security exception must be configured to enable the root access. So this is the parameter we generally keep disabled. So root can access the NFS shared mount point. And if you are using version 4.1, we also support Kerberos authentication. So first time this Kerberos authentication, NFS version 4.1 introduced in 6.5. In addition to identify verification, it provides data integrity services. And these are the algorithm being used for the encryption purpose. And if you see the NFS data store property, it will show to you all the options. the server name. Currently 2 hosts using it, and we are using NFS client version 3. And the same information we can retrieve through the commands, which is the NFS target server name, storage name. If you're using version 4 with Kerberos, you must perform following tasks. Active Directory you need to integrate. Active Directory based user can get the permission. AD enable in one of the following encryption methods. And this is not supported in vSphere 7. And verify NFS server exports are configured to grant full access to the Kerberos user, to the AD users. AD must be integrated with the vCenter server, so AD user can get the permission to mount these NFS data store to the ESXi host. And when you select ESXi configure tabs, and here we have also option time configuration. So now let me know the ESXi host working as the NTP client or NTP server. Anyone? ESXi works as the NTP client or NTP server?
NTP server.
It works as a both. For the virtual machine, it can play a role as a NTP server, but for itself, it is NTP client. Must rely on external NTP server. You must need to prepare 1 or 2 NTP server, and here that information you need to provide. So from this NTP server, all the ESXi host continuously updating date and time, very important, specifically to retrieve the logs file. I want to get the particular logs file of this date and time. That correctly log file you can grab if you have NTP server proper syncing, the ESXi proper syncing is time from the NTP server. But if you have virtual machine running on the ESXi host, if you edit the setting, you have a 1 check mark, sync time from the host. So for virtual machine, it can play role as NTP server, but for itself, it is always NTP client. Configuring host authentication services. So first main conditions we have AD integration. Active Directory must be integrated with the vCenter server, so we can see the AD-based account. For them, we can provide accessibility. You can automate this configuration with host profile. And you can set up username, password by running the command also. And use the same AD user on all ESXi host while you mounting the same data store. vSphere, vMotion, other components might fail if individual host level you are using different user account. So it is mandatory to have same account while you mounting this NFS from all the ESXi host. And that is also equally important when we're going to perform vMotion, move the memory state from existing host to new host. So the same user having permission on the both hosts, so vMotion gets successful. So for this purpose, we can use host profile. If you want to make from the configuration point of view, identical all the hosts. So first you have a one host, reference host, do all kind of configuration here, then create a host profile, and this host profile you are going to apply to other host. So once you apply, now every host get the same configuration. So you have an option while you creating new data store with the client version 4.1. Are you going to use or don't? So you have an option. Enable Kerberos authentication when creating each data store. You can use for the same configuration host profile. So again and again, you don't need to configure the same configuration. Apply the host profile and all ESXi host get the similar configuration. So now we have two labs. Labs number 9, run the break script. It will create some problem. You need to figure out the problem. And whatever we discussed, only those you need to concentrate. Rescanning, VM kernel, physical adapter, these are the main things. CHAP, authentication that you need to find. iSCSI port number, targeted IP addresses. VM disk activity, review the ESX top statistics, and monitor some of the storage related counters. So 2 labs we need to complete, 9 and 10. So first we can take a lunch break, tea break, and come back and you can start working with the lab number 8 and lab number 9. Is that fine?
Yeah, Girish.
Okay, thank you.
Yeah,
So
that's
take
fine.
a 15-minute tea break.